Okay, and I'm using new technology for the first time. I'm using my iPad instead of my laptop. So bear with me while I get used to this new system. Hopefully you can see in front of you a grid with numbers, and at the top it says YouCubed Tic-tac-toe sums 1. Everybody see that okay? Dave, can you indicate that you can see that?
Yes, I see it.
Okay, great, thank you. Okay, so as the name suggests, this is going to be very similar to a tic-tac-toe game with some differences. So we're going to attempt to get 4 tokens in a row. Sorry, maybe in this version, we'll just stick with 3. So 3 in a row. And this is a 2-player game. And you want to get 3 in a row, but in your color. So each player will be given tokens. So one player might have green tokens and another player might have red tokens, and we'll place them on the grid. And you try to get 3 in a row of your color. And the numbers at the bottom are what we're going to use in order to find sums on the board to place your tokens. So let me give you an example. So let's say the first player, so what we do at first is we put a token underneath a different kind of token. These don't belong to any players, but so I'm going to put a token under the number 4, for example. And then the next player, the other player, they pick a number down at the bottom here and also put a token or a mark or a circle or an underline, as I'm doing, under one of these numbers. They can choose to put it under the 4 also, or pick any other number. So let's say they pick 8. Then because this game has to do with sums, so they're going to add these 2 numbers and put one of their tokens, their color, on the number 12. So what I'm going to do is I'm going to say that player is green, and I'm going to circle 12 for them. Now it is the other person's turn. And so on my turn, I have to move one of the tokens at the bottom, one of these 2 tokens. Let me change my color here. So I'm going to move this one or this one to a different number. I must move one of them, and only one of them. So let's suppose I move the token away from the 4 and move it to the 5. And again, I could move either one of those tokens at the bottom. Neither one of them belongs to me per se. So since I moved it to the 5, now I have a sum of 8 plus 5. And let's say I'm the red player, so I'm going to put a token of mine on the number 13. So would anybody like to volunteer and be the other player who's playing against me now?
I'll do it.
Okay, and your name?
Perfilia.
Okay, all right. So can you explain to everybody, so what do you do when it's your turn?
I'm going to pick a number from the box and then underline the numbers that will add up to the number that I pick. Am I right?
Okay, pretty much. So let me just remind everybody. So both of us are trying to get 3 in a row on the board. And I should specify, it can be row, column, or diagonal, just like the typical tic-tac-toe game. So now I forget already. You're the green player, is that? Yeah, you're green. So right now, one of your tokens is at the number 12. And you're trying to get 3 in a row, preferably using that 12 because you already have a token there. And yes, you're right. So on this turn that's now yours, you get to move either one of these tokens to a different spot and try to get a different sum that will help you get 3 in a row. So go ahead. Which one would you like to move?
I'm not really sure if I understand it.
Okay, you're moving one of these. You need to move one of these tokens down here in order to get a sum that's on the board. So for instance, if you moved this token from the 8 and moved it to the 10 instead, then now you add 10 plus 5. And you would get 15. Now that may not be a number that you want to get. So let me erase that and let you decide.
Oh, okay. Okay.
Does that make sense?
Yeah.
Okay.
I'll move it to the 12. Can I move it from my computer to the 12?
I guess I'll have to do it. I think I have to do it for you. You want to move it from the 8?
Yeah, from the 8 to the 12 and then circle 17.
Okay. Aha. Okay. Nice move. Okay, now it's my turn. And remember, we're trying to get 3 in a row. So I've got to figure out a way to block you. Okay, so I'm going to move the token from the 12 to the 2. And I'm the red player. So now I've got the 7.
Okay. Okay, so I'll move I just move one token at a time?
Yes, either one.
Okay.
And remember, both tokens can be at the same number if you want them to be, but you just move one at a time.
Oh, okay.
On your turn, just move one.
Okay, move the 2 to the 3.
Okay.
And so that'll equal 8.
I forget what color you are. You're red, right?
Green.
You're green. Okay.
Yes.
Okay. Gosh. Yeah.
This is fun.
I was all ready to win the game, but now I realize I cannot get the 1 right now. Oops. Wonder how I did that. And I cannot get the 19 either. I don't think. No. Darn. Okay. So, but now I shift to, I need to block you. So, uh-oh.
Oh, she can win with the 22, maybe.
Oh, I forgot about the 22. Wait, but I can't remember,
Block her some way.
I can't move both of these at the same time. Or are you saying the green
Better off
player? can
blocking
win?
her in the 16. Because she can't, I don't think she can add up to 22.
No, I tried that.
Okay, let's see. I haven't had,
I would block her on the number 4 because she has number 4, she can win, or she can either win with the 16.
Oh, that's right. Block her on the
So-
4.
Yeah,
Oh,
I
don't
would
hit
block her on the
four.
Good strategy. You have 3 things, three ways.
oh, wait, I'm not green.
You're
No,
red.
you're red.
Oh, where's my pencil? Okay,
Okay, let's see. Okay, move the 1 to the 8 and circle the 11.
and circle
yeah.
the 11.
I'm sorry if I missed it, but can you do 3 and 3, for instance, or not?
Yes, yes. You can put both tokens on the same number. Yes.
Thank you.
Mm-hmm. Okay, I need to, let's see.
Okay, now you can move the 7 to the 2 and circle the 5.
And you won. Good.
Yep.
Oh, wow. Okay. 7 to the 2 and get the 5. 3 in a row.
Yay.
Excellent. Okay.
Good.
Nice job. Okay, so comments. What are students practicing when they do this?
They're practicing putting add-ins together,
Okay,
finding missing numbers.
okay.
Planning,
Say that again, please.
planning ahead,
Uh-huh, sure.
a little
Mental
bit like
mental math.
chess.
Okay, strategy and mental math. Mm-hmm.
I see a ton of critical thinking skills. Having to analyze and synthesize the logical reasoning is crazy.
Okay, yeah. And I guess I'm not a chess player myself, but I guess in chess, you need to think several moves ahead to kind of plan your strategy. And there's a similar element here. You know, you pick certain numbers, but you have to think ahead. Will they be able to get this number on their next turn? Other comments?
I'm sorry, but I just joined. I guess like spatial relationship, like where the numbers are spaced out for them to get used to visualizing seeing numbers from a distance.
Oh, okay, okay, sure.
I like the perspectives part of it too, since you have to hop back and forth between offense and defense.
Okay, nice. Yeah, that's very true. As I said on one of my turns, I was ready to do 3 in a row and then realized I couldn't. So then I did have to shift to defense and try to block the other player.
Could you do more than 2 players?
I don't know.
Tic-tac-toes like usually.
Yeah, I mean, I would encourage you to try that.
Maybe two teams.
Two
Yeah.
teams, yeah, sure. Uh-huh.
With this also work, like not just with addition, but subtraction and multiplication and fractions.
Oh, boy.
mean-
I would,
Or
I
more
would
like students that are performing above grade level.
okay. I would definitely encourage you to try that, to experiment and, adjust any of these activities for where your students are.
You can also use what unknown variables, right? Is this too early in stage? Unknown variables like A, B, C, D, E. I don't know.
Oh, interesting.
So you could do like the 0 as an operator, like a plus, and then you got A, B, C on the left side, A, B, C on the top, and then putting different letters in there and have them teach them like A plus A equals B kind of thing. I don't know.
Oh, I like it. Wow.
This is Anita Manuelito, and it is also good to challenge your learners with this activity.
In what way specifically do you think?
I would say just the addition and a lot of mental thinking.
Yes, I agree. And I think it's interesting that like on any turn, you're not just doing one addition problem, you're doing several, right? To sort of, and you're constantly looking at the bottom here. You have to play with these numbers down here. You have to play with different numbers up here. Can I get this? Can I get this? Can I get this? Just by moving one of the tokens at the bottom. So you might be doing several addition problems on a turn.
And it could also be good to do, to use it as an assessment.
Sure. Uh-huh. Yeah, I mean, you're doing sums up to 24. And that's, the maximum number you can get is double the 12. Yeah, so you could say this game specifically helps students practice sums up to 24. Great. Okay, now if they're doing this in person, which would be the ideal way to do it, so you could have little tokens at the bottom, like little paper clips or whatever you want to sort of indicate the two numbers at the bottom, and then use two colored tokens, maybe those see-through kind, to place on the numbers on the board. You probably don't, I mean, pencil and paper would not be the ideal way to do it, I think, because then students might have to erase if they change their mind, and the board can get kind of messy that way. And it's more interesting to introduce the kinesthetic aspect of it so the kids can move the tokens themselves. So, but it does work pretty nicely in a virtual setting. So just to show you it, so this is the second board that they offer. So what do you notice about this board?
I think there are
The sums are doubled.
Doubled?
There are
The
two of
numbers
each
are
number.
greater. The numbers are greater?
Are they bigger?
Yes.
They're double digits.
Yeah, they're doubled. They're not all double digits, but they are double in number. There's 2 1s, 2 2s, 2 3s, and they're not in order from 0 through 24. Now the rows, there are 10 rows, or yeah, 10 rows, but still 5 columns.
Okay, excellent. So just to remind you, on this previous board, the highest number was 24, lowest number was 0. And is that still true here? The smallest number and largest number?
Yes.
Okay. Yeah, and I think you're right that every number appears twice. And also someone noticed that they're out of order or in some kind of random order, I think. So how would this change the game, or would it very much?
Oh, it would. You have to pay very close attention to all the possibilities.
Uh-huh.
More possibilities too.
Right. Yeah, just that idea that 21 is now on the board twice. Where's the other one? Oh, there it is. So if someone does have tokens there, they get to choose which 21 they want. Which one would help their strategy more. And then when it's the next person's turn, suppose they want the other 21. Well, they cannot leave the 2 bottom tokens where they are. They must move one of them away. So the other person cannot get 21 right now. They cannot get the other 21. So remember, on every turn, you must move one of the tokens. So this could be an interesting board to use when you're doing sums. And now someone mentioned multiplication.
Yes, yes.
Yeah. And I believe the directions on the YouCubed site say now we're trying to get 4 in a row. It sort of depends on the size of the grid. I think with that first one, 3 seems more reasonable just because the grid is smaller. So with the larger grids, you could do 4 in a row. So one last question about these. So what grade levels do you think? So we have tic-tac-toe sums and we have tic-tac-toe products. So what grades do you think these would be appropriate for? And would you use them in your classrooms?
I think it would be 2nd grade through 4th grade.
Okay.
Or up
And
to
for-
6th grade, maybe. For remediation teaching for some up to 6th grade.
Okay. Would
Of
there
course,
be
with-
go ahead.
So of course, with the sums 1, it would go lower than that too. Like I think 2nd grade, for maybe even 1st grade.
Okay. Would there be a way to adjust this to make it more accessible to 1st graders?
maybe make the box smaller with fewer choices, or maybe like a 3x3
Or lower numbers, smaller
Uh-huh.
numbers, like to
to
10.
10.
Sure, and maybe maybe get rid of some of the numbers at the bottom as well to match the board, the smaller board. Yeah, so I would, encourage you to experiment with that and adjust this for lower grade levels or higher. And maybe maybe the object isn't to get 3 in a row anymore if the board is so small. Maybe the object is just to see what numbers you can get. Just open it up more. Okay, any last comments on the tic-tac-toe activities?
Oh, I have an idea. If this is going to be done on paper, I think I would put it in a see-through insert it into a see-through what do you call it? Or laminate it.
Yep.
And students can
Sheet
use dry erase marker. Yeah, sheet protector. And then students can use dry erase markers.
Sure, that would be one way to do it. Yeah. Not use as much paper. Erasing is a little bit easier. Sure. Nice idea.
I was thinking, for the sums too, if you are doing multiplication, you would continue to go from 0 to 12 at the bottom, but in the squares, you would just put the numbers of the multiplication table that you are doing, like for the multiples of 3. Just don't mix them up. Just go. I don't know how many squares, rows, and columns there would be though, but that's something to try.
Sure. Yeah. And again, experiment with, and that's kind of interesting because then there might be some combination of numbers on the bottom, but there wouldn't be a number in the grid. The answer 54 might not be in your grid. So they would have to look up and be careful about where they're putting the tokens on the bottom. If I understand. Yeah. Yeah. So I think you could experiment quite a bit with adjustments as needed for your students. Okay. Before I show you the next activity, let me just give a plug to the website where I found these. If you just Google YouCubed, you'll find, a site with a lot of different tasks. And the person behind this project is Jo Boller from Stanford University. And she has a pretty popular book out. I think she has a second book out now also, but the first one was, I think I have that title right. It's pretty close anyway. Mathematical Mindsets. That's her book. But so think about YouCubed, the website, as a resource for lots of different tasks. Okay. The next one is, and this is also from that same website. It's called Get to Zero. And I have to bring up an app on my phone for rolling dice. Okay, and so the idea here is we're going to start with the number 999. And then I'm going to roll 3 dice. And I got a 5, a 6, and a 1. And my job here is to arrange these 3 individual numbers into a 3-digit number any way I would like. So I could make 516. What else could I make?
$651.
Okay. What else could I make?
615,
Okay.
156,
Mm-hmm.
165,
Uh-huh. So I lost track. I'm not sure if anyone said 561.
No.
Okay, so I think those are all the possibilities. And our goal is to, once we arrange it the way we want, so I'll just choose 615. Now we're going to subtract. And what do I get?
384.
Okay. My goal is to get to 0. And this is a 2-player game. I suppose it might work with more than 2, but let's imagine 2 players for now. So we're going to take turns, and the first person who gets to 0, and you have to get exactly to 0.
Mhm.
If on your turn you're unable to get to 0 with the numbers that you rolled on the dice, you lose that turn. Now, another thing, as the numbers get smaller, you might not want to roll all 3 dice. So at any time, you can decide, oh, I'll just move 2 dice on this turn, or just 1 die. Questions? Okay, I don't hear any questions. So how about a volunteer to try this with me?
Okay, I'll go again.
Oh, okay. You're going to continue your winning streak? Okay, so if you trust me with my little app here, that's from a website called random.org, I'm going to roll the dice for you. Is that okay?
Okay.
Okay. Okay, I just rolled the dice, and these are your numbers. And could you explain to everybody what you do on your turn? What is your job on your turn?
Okay, so my goal is to get a 0 after subtracting by moving those numbers around, to any 3-digit numbers, and subtract it from 384 and try to get a 0.
Okay, nice.
Okay, so I'll do 332.
Okay.
So that would be 52.
You sound like you're not sure. What, did I hear a question mark there?
I was still subtracting. Okay, that is 52.
Okay. Everybody hear the change in her voice? The first time I heard a question mark. Second time I did not hear a question mark. Okay. Now this time I'm just going to I'm just going to roll 2 dice because I don't want to go into negative numbers. I got a 1 and a 6. So 46, 36. Okay. Okay, it's your turn. How many dice would you like me to roll for you?
2.
Okay. You got a 4 and a 6.
Okay. Oh gosh. I can't use it either way. So what do I do here?
Unfortunately, you lose the turn.
Oh, okay.
And I should clarify for everyone. I mean, we could, I guess, go into negative numbers, but according to the rules of the game, we avoid negative numbers, and we just both are trying to get to 0 on the dot. However, if negative numbers are something you want to explore in this game, and you want to make some rules as to how to deal with those, I'm all for it. But for now, let's just say she cannot use the 46 and she cannot use the 64 without getting into negative territory, so she loses that turn. Okay, I am going to, just to be on the safe side, I'm just going to roll 1 die. And I got a 5. So obviously there's only one thing I can do. Okay, let me erase some of that to make some room. And everybody else, I would encourage you to be thinking about, what are students doing in this game? What skills are they practicing? What might they be getting out of this? Obviously they're subtracting, but are there other things going on? And what grade level might this be appropriate for, etc. Okay, how many dice would you like me to roll for you?
I'll chance it and go with 2 again.
Okay.
Hopefully I get a 3 and a 1.
Okay, you got a 6 and a 2.
Oh, okay, that'll work. Okay, so 31 minus 26
Okay,
equals 5.
excellent. Okay, I'm going to roll just 1 die. And I got a 2.
Okay, die.
You got a 6.
Okay. So I lost my chance there.
Yes, sorry. I just rolled and I got a 1. So let's see. 3 minus 1 equals 2.
Okay, 1 die.
Okay. And you got a 6 again, sorry.
Okay.
I rolled and I got a 5, can't use it.
Okay, so 1.
Okay, and you just got a 2.
Woo, all right.
Oh, your winning streak continues. Okay, excellent.
You brought
Comment.
up how we could modify this. You know, you have dice and you have subtraction, but obviously depending on the level, multiplication, it doesn't have to be going down to 0. It could be who wants to be a millionaire or billionaire. you know, maybe some exponents and things like that. So there's ways to change up the equation. It's still the same concept of some of the things that you did, but change obviously the skill level.
So are you saying, like, if you get these two numbers, you can multiply them then? And then are we still subtracting here?
You could multiply, you could do exponent, you could go up to 1,000,000,
Oh,
fashion
okay,
it that
okay,
way.
okay, sure. Mm-hmm. Yeah, definitely change. You can change your target, change the operations. I like it. Like you said, depending on the skill level, depending on what you want to emphasize. Other comments?
So with this game, does it always start with 999? 999?
Yes. However, I think it would be interesting to start, you know, with 9,999, or conversely, how about just 99? Again, depending on your students, depending on skill level. Or you could just say to them, you know, give me a random 3-digit number and we'll start there. What other things are going on in this activity, in the original activity? Without the adjustments?
I like the emphasis on place value.
Yeah.
Yes, exactly. Yeah, they get to play around with place value a little bit. Remember that first roll was a 5, a 1, and a 6, and they get to decide what 3-digit number to make, and think about how does that change the game? How does that change their subtraction problem? If you're subtracting 600 and something versus 100 and something, it's going to change the game quite a bit.
They get to practice their regrouping also.
Absolutely. And by the way, in our one game we played here, how much regrouping did we have to do?
Not that much.
Yeah, not really. And I should rephrase that. How much did we get to do? And I think it only occurred right here. And did anyone, I think this was my turn. Did anyone catch how I did this subtraction? Did anyone hear what I was doing?
I noticed you counted by 10, counted up by 10. I heard you say, I didn't hear you say 26, but you said 36, 46. So you kept adding 10.
Right, yeah. Actually, I don't think I was adding, but I subtracted in 2 pieces. So I took the 6 away first, I think. So I said 46. And then I took the 10 away and got myself to 36. So I just broke it up into 2 pieces. Adding up would certainly have worked. So you could, you can let students experiment with their subtraction strategies. Did anybody notice how I wrote these subtraction problems?
Linear, like an equation going across.
Yeah, they're all going across. And I did that very purposely. And I'd encourage you to experiment with that with your students. But, these first 2 problems, for example, I'd love to hear students just kind of read off the answer as someone here in the group did. They can just see 900s minus 600s. I have 300. It's totally different from, I think, what we often teach. They usually don't subtract the hundreds first, do they?
No. But
Yeah.
there's some, I'm currently doing 4th grade math, Eureka,
Uh-huh.
and their philosophy is to set them all up so you're able to subtract each one. Where I was taught, worry about the ones, then worry about
Yeah.
the tens, but they're saying set the table, do all the, what they call it, borrowing, regrouping, or people say decomposing, breaking that down and bringing that 10 over and setting it all up before you just go rapid fire, boom, 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 subtracting.
Okay. Okay. That's interesting.
That's how it is also with Go Math,
Okay.
with the partial products.
Mm. Well, I think this activity would give you lots of opportunity to experiment with, with different subtraction techniques. And sometimes it depends, if a student wants it to be 615, then they might subtract a certain way. If they change the number, then they might decide, oh, I think now that I have these different numbers, I'm going to use a different subtraction technique. So it's great if they have different subtraction tools in their tool belt. Other comments, ways we can adjust this for our students. We talked about some at the beginning, change operations, change the target number, change the starting number.
It'll be challenging to change the starting number to 1,000 because students usually have trouble subtracting from 0.
True, true. Yeah, I suppose that's why the authors chose the nice number 999, at least at the beginning. Good point.
What about the other way around, like for addition from like start with 0 and then your max is 999?
Sure.
I don't
Oh,
know.
yeah. Definitely. And then you might want to adjust. Now, they probably won't ever want to use just one die, right? Well, unless they get, no, I'm sorry. If they get close to when they get close to 999, they might decide, oh, I'll just use 2 dice or 1 die at the top end. Yeah, nice. Okay, I'm going to move on to one more pretty easy activity to go through. I just wanted to kind of put this out there as an idea. So I'm going to use my dice roller one more time. Okay, so this, I think the directions describe this as a 2-player activity, but I think there's no reason why you couldn't do more. I rolled the dice and I got a 2 and a 4. Oops, sorry. I just realized something. I'm supposed to just roll 1 die. Okay, so I got a 6. So that means I'm going to draw for myself 6 circles. And now I'm going to roll that die again. And I got a 2. And the 2 tells me how many stars to draw inside the circles. So what do you think is the underlying activity? So underlying idea of this activity so far?
It's a multiplication, right?
Yeah, it's definitely multiplication. I suppose you could, you know, if you wanted to, for younger students, introduce it as an addition activity, but obviously you're planting seeds for multiplication. And then the way the website suggests to play is now it's player B's turn, and they're going to roll one die, and they got a 3, so they're going to just draw 3 circles. And if you play this in a competitive way, you know, player A and player B want to get the most amount of stars at the end of, say, 6 turns back and forth. So, and one thing you could sort of discuss or again, plant the seeds about this idea is, what number or numbers is player B hoping to roll in order to get more stars than player A got? What does player B need to roll?
5 or a 6.
5 or 6.
6.
Oh, yeah. Mm-hmm.
Because 4
Okay.
would tie, right? And is tying okay?
It depends on how competitive your students are, I guess.
Wait.
Oh, so I just rolled the other number for player 1 or player B, and I got a 1, sadly. So that didn't work out so well for player B. And then that's pretty much all there is to the activity. You play this a number of times and see who gets the most stars all together. But of course, you know, adjust this however you want. Change it to, maybe it's not a competitive activity. Maybe it's just going back and forth and seeing what happens. Maybe you can, as I said, it could be many players. I don't see why it couldn't be many players doing this, taking turns. It could be a solo activity. What do you all think? What are your comments about it? What grade levels could do this?
I like this game. I think the way things are right now, we can't sit too close to each other. So I was thinking, I wonder how we could have students do, you know, play this game, but not be so close to each other. Other
Maybe
than
a Jamboard? If they had a Jamboard each on their own computers where they could see what each other is doing.
Okay, thank you.
I see 3rd grade having a lot of fun with this one.
Okay.
I think practicing arrays would be a good idea also. They could choose to do 6 rows, 2 columns, or they could choose 6 columns and 2 rows.
Sure. They could use whatever manipulative you wanted them to in order to model this. They don't have to do it with the circles and the stars.
Perhaps even the fact families.
Right.
Then you can start working over into division.
Oh. Yeah, and your comment about the fact families. So suppose this player rolls that 6 and draws their 6 circles, and now you could pose a question, you know, what happens if you roll a 2 next? What happens if you roll a 4? What happens if you roll a 6? So practicing all of those, ooh, 6 times 6 would be 36. 6 times 1 would be 6. So definitely you could practice all the 6 facts, or at least up to 6 times 6, because you're using a die. And the website suggests that when you roll your second number and draw the stars, then you could have students practice writing a number sentence that models this. And you can decide, to do that or not to do that. If you want to emphasize, having your students write the associated number sentence, this would be a great activity for that. Other comments? Okay, I have one more activity to show you. And I need a volunteer.
I can volunteer this time, even though math on a Saturday is kind of scary.
Understood. Sunday through Sunday works, right? Math on Saturday can be fun. We're having fun. Okay. I'd like you to choose a number and don't tell me what it is. That is on one of these cards, or more than one of these cards. Choose one number, don't tell me what it is.
Okay, I got it.
Got it? Okay. Is your number on the first card? And by first, I mean this one. Is your number on that card?
No.
Okay. Is your number on the second card over here?
No.
Okay. Is it on this third card?
Yes.
Okay. Is it on the fourth card?
Yes.
Okay. Fifth card?
No.
Okay. And the last card?
Yes.
Okay. Is your number 44?
Yes. Very nice. You're a magician.
Oh, okay. I did a little bit of math on Saturday.
And magic too.
Correctly. Yeah. Okay.
So tell us your secrets.
Oh, not so quickly.
Oh.
Would someone else like to try?
I'll
Can I
try.
Okay, can you pick a number that's on there, please, on any one of the cards or multiple cards, and don't tell me.
Yes.
Got it?
Yes.
Okay. Is your number on the first card?
Yes.
Okay. Is it on the second card?
No.
Okay. Is it on this card?
No.
Okay. The next card?
Yes.
Okay. The next card?
Yes.
Okay. And the last card.
No.
Okay. It's a little trickier. I think your number is 25.
Yes.
Wow. Okay.
How you do that?
Okay, that's for you all to figure out.
She can read our brain. She can read our mind. No kidding.
Yes, that's what it is. That's what it is. Like only on Saturdays I can do that telepathy kind of thing. Okay, so let me ask you some questions. What do you notice? These are the same cards that were on the previous slide. What do you notice? It can be anything.
Different cards have different combinations of numbers.
Okay.
Each card has like the first card has 25. The second one doesn't have it. The third one has it. And then on the second column, it doesn't have it. And on the fifth one, it has it. And then the last one doesn't have it. So when you, the 25, if you go all look for that 25 and you're asking, is your number on the first card, second card, and so forth. And you already kind of guess what numbers are on those particular cards. And the same with 44. I guessed 44 the first time and you got it. Because it's not on the first one. When you asked, is it on the first card? She said, no. Is it on the second card? Yes. Is it on the third card? No. Is it on the fourth? No. And so forth. Fifth card, yes, and so forth. And you only had those, like the 44, you only had 3 of those cards left. And then you started getting particular, like, you know that there's a 4 in that second card, but no 4 in the fifth card, and no 4 in the sixth card. So you're kind of going based on that. I found out.
Okay. All right. Great.
I don't know if I made myself clear, but or I just confused everyone.
I noticed the sequencing of the numbers. The first card skips by 2, 1, 3, 5, 7. The second one, 2, 3, it skips a number. It skips 4, and then it goes 6, 7. So every third number it's skipping. The third one.
Okay, I'm sorry. Can you slow down? Can you slow down just a sec? What did you tell me about this card?
It skips every third number. 2, 3. It skips 4, and then it goes 6, 7. It skips 8. So it's starting with 2, but it skips every third number.
Does it? So what does it skip here between the 3 and the 6?
Oh, it skipped the 4 and the 5. Okay, so it skips 2 numbers.
Okay.
Yeah, so it skips 2 numbers, and then 6, 7. It skips 8 and 9.
Okay.
And then 11. It skips 12 and 13.
Oh, so it skips 2 numbers on the second card?
Yeah, it's 2 numbers.
Okay.
And then the third one, 4, 5, 6, 7, 8, 9, 10, 11. It skips 4 numbers. It starts with 4 and it skips on the 5th number. It starts to skip 4 numbers. So 12, 13, 14, 15, 16, 17, 18, 19, and then it jumps to 20.
Okay, does everybody see what she's describing here? Do you have questions before she goes on? So let me just restate that if you don't mind. So she said on the second card, so on this card, it starts at 2 And when it skips numbers, it skips 2 numbers. The 4 and the 5 are skipped. And then here again, the 8 and 9 are skipped. So skipping 2 numbers every time. 12 and 13 are skipped. And then, thank you for letting me clarify that. So what happens on the next card?
Okay, on the next card, it starts with 4.
Uh-huh.
It adds 1 up to 4 numbers, and then it skips 4 numbers. So 4, 5, 6,
Ah.
7, and it's skipping 8, 9, 10, 11.
Hmm. Starts at 4. And then 4 consecutive. And then skip 4. Huh.
Mhm.
Anybody else want to guess what's going to happen on the next card?
Can I try?
I'm sorry.
Oh, okay, I want to try the next one.
Okay, yeah, please.
Yeah, for the next card, it starts by 8,
Okay.
and from 15 to 24, it skips by 8 consecutive numbers. Then it starts with so it starts with 8 and it skips with 8 consecutive numbers.
Nice. Okay, so these are all consecutive numbers, 8 of them. And then you said between the 15 and the 24, how many
Yeah.
numbers are omitted?
8 numbers,
Okay.
8 consecutive numbers.
16, 17, 18, 19, 20, 21, 22, 23. Yeah, 8 numbers are skipped or omitted. Does that happen again?
I think from 31 to 40, 31, 32, 33, 34, 35, 36, 7, 38. Yeah, 32 to 39 are omitted.
Okay. Okay, great.
And yep, and then last is 47 to 56. 48 to 55 are omitted.
Nice. And since I'm getting a little short on time here, I think we can kind of see, does the same thing happen on the next card?
Yeah.
Starts at 16. So if the pattern continues, there should be 16 consecutive numbers.
Yeah.
And we already said that's a row of 8, and there's another row of 8. So there's 16 consecutive numbers, and then a big gap. How many numbers do we think are skipped?
16.
Yeah. And then 16 more consecutive numbers.
So I see the pattern, yeah.
Yeah. So there is a definite pattern to how they made the cards. This one starts at 32, and it should have how many consecutive numbers? If the pattern continues.
$32 consecutive numbers.
Yeah, exactly. Because remember this one, it started at 16, had 16 in a row before a skip. This one started at 8, had 8 in a row before a skip. So this one should have 32 in a row, and that takes you all the way to the end. So there's really nothing got skipped at all between the 32 and the 63. So interesting pattern. Other things anyone is noticing?
The numbers that are skipped are doubled in each card.
Dou-
And it starts with 1. First one is, it skips by 1. Second one skips 2 numbers,
Uh-huh.
4, and then 4 times 2 is 8.
Oh,
8 times 2 is 16. 16 times 2 is 32.
oh. I'm just going to write down on the next card, we skip 16. Okay, so these numbers I've just circled over here, you're saying they're doubling every time.
Yeah.
Nice. And what's the smallest number on any card? In this whole picture, what's the smallest number?
1.
Okay, no 0. We don't have a 0.
No.
And the largest?
63.
Other things you notice? Or wonder about? Anybody have questions? I think we have 3 more minutes if I remember the schedule correctly.
Could one be that they're factors of 2? Or factors of, see if you 2 times 2, 2 times 4, 2 times 8.
Okay. So you're referring to these numbers that we were just talking about?
Mhm.
Are those factors of 2? Anybody? Are those factors of 2?
Yes, they are.
Factors or multiples?
Multiples.
Yeah.
Both.
No. They're doubling. They're multiplied by 2.
Okay, so I agree, they're definitely doubling. And by the way, where else do you see these numbers besides over here where I've written them and circled them many times?
At the beginning.
At the beginning of what?
At the beginning of each card.
Uh-huh, okay, at the beginning of each card. And does everybody agree that those are multiples of 2?
Yeah, they are all multiple of 2.
And I'm wondering how they all end with 63.
Oh,
How did that happen?
so 63 is on every card?
Yes.
Is that the only number that's on every card?
I think, oh no.
Yeah, you notice
Yeah.
that for card number 3 and number 4, 8 minus 4 is 4, 9 minus 5 is 4, 10 minus 6 is 4, 11 minus 7 is 4. That makes sense?
No, I'm sorry, you lost me. Can you say that
Oh.
again, please?
Yeah, for card number 3 and 4, when you try to skip, so 8 minus 4 is 4, 9 minus 5 is 4, 10 minus 6 is 4, 11 minus 7 is 4. Same thing with 5 and 6. 32 minus 16 is 16. 33 minus 17 is 16. I don't know what is the relation of those.
Oh, I see what you're saying.
Mm-hmm.
Okay, let me do some drawing.
Mm-hmm.
So 8 minus 4.
Right, is 4. 9 minus 5 is 4. 10 minus 6 is 4, and so on.
Oh, interesting.
But at the end, they do have only the same number, 12, 13, 14, 15. And that makes me... Same thing with 5 and 6 card. 32 minus 16, 33 minus 17. But at the number of... Oh, no, I think 39 minus 23 is also... 39 minus 23 is 16. See that? 38 minus 22. I don't know what is the relation, but the problem is what I observed for card number 3 and 4, for 13, 14, 15, they are just the same.
Right.
Mm-hmm.
Okay, and I know I'm going over time just a second here, but this is pretty cool. So now you're seeing that 12 minus 12 is 0, 0, 0,
Mm-hmm.
0. What happens if we keep going? How about this 24?
Or 25 minus 21 is same thing, 4, but
oh, so we're back to
they
fours.
are also 0 for 29 to 31.
Can I say something?
Yep.
What if, like, so the last card is 32 and it goes all the way to 63, it's added by 1. So anything, any number that someone picks in that rank, I mean, is above that number, so it's going to be like a count by 1. But any other numbers might be under a condition, like for anything below a certain number has to be set up differently. Do you know what I mean? I don't know if that makes sense. The last card is 32 all the way to 63. It's added by 1.
Right.
So
you're saying,
anything above 32 could be, yeah, like that's just like a norm. It's just added by 1. And then
Right.
the other cards are within certain integers that might have a different condition set up, if that makes sense.
yeah.
So the last 2 cards looks like it starts, they're all added by 1, right? 16, 17, 18, 22, 23, all the way to, yeah, that first part. I feel like you have to circle where all of them are added by 1.
Right. I mean, there are consecutive number streaks on each card, but they start with really short streaks, like the shortest possible streak, and then we get a little bit longer, and then longer.
Yeah.
Yeah. So unfortunately, I'm going to need to stop here, but you guys have noticed a lot of things that's going on in these cards. And I would invite you to think about it further, take this, I would say take this home with you, but most of you are home right now already. Think about this more, see if you can see some more patterns and try to figure out the secret, if you will, about how I knew what your number was.